Alright, so this is a quick video to go over what we did in chemistry class today. So we did on page 48 of your notebook, you should have the notes for these lessons glued in. I'll put those notes on the screen in a second, so you'll be able to copy them down if you're stuck at home. Page 49, you have the lesson reviews for those lessons. Again, I'll put those on the screen in a moment, and you'll be able to get those if you need them. They're also in your digital textbook. All right, and then we did some scientific notation practice, and we'll go over that as well. All right, so first of all, you should have this in your notebook. So the red information are the answers. I'll try to attach this PDF with this video in case you're missing it. But those are the answers. Okay. Remember, scientific notation is just making the first number between 1 and 9, and then however many times you move the decimal, that's the exponent for the 10. Okay. And if you move it to the left, then you're going to have a positive exponent. If you move it to the right, you're going to have a negative exponent. Okay, so in this part, you identify which ones were correctly in scientific notation. So you didn't have to convert anything, you just had to know if it was right or not. These three are correct because the first number is between 1 and 9, and you have the exponents. These three are incorrect because this one is more than 9, this is way more than 9, and this is less than 1. All right, and here you had to write each number in scientific notation. All right, sorry about that. That was my phone. It's not a drill or anything. So here you have the answers for this. So pause here and make sure you have all these answers in your notebook. All right, so moving on. So this is the next section. And again, here they give you standard notation, and you had to convert it into the scientific notation. All right, so pause the video here and make sure you have the correct answers. And remember, you can always take a piece of paper, cover up the answers, and then test yourself. You could even in these you could cover up the question and quiz yourself. Okay, so there are ways to study other than just reading the same thing over and over again. All right, so here we have standard notation, and we have to convert it into scientific notation. Notice that they all start with a number between 1 and 9, and then you have the exponent. Alright, so you should have these correct answers down. If you do not, you can pause and we'll move on. Alright, so here there's actually a mistake in the answer key. This one should be 3.9734 times 10 to the 5th, and you would convert that to standard notation, and you have 397,340. Alright, so again, pause the video here and make sure you get all the answers. Alright, and then you should have this one as well. And so this one, with a triple beam balance, you're going to take and add the hundreds place, the tens place. Let me use my laser pointer. The hundreds place and the tens place, and then you're going to add the ones place. So when this says 1, that's 1. And then there are 10 spots in between. So that's, 0.1, 0.2, 0.3, 0.4, so forth and so on. Now, when you're measuring, you can go one decimal place farther than the smallest increment on the device. So we know it's 400, and we know it's 30, and so that's the 430. And then we've definitely got at least 0.3 here. So that's going to take, we can go one more and say, all right, it's almost at the 0.4. So that would be 430.39. All right, over here, you've got the 100, the 80, and it's a little more than 0, but it's not quite 1. So 180.05. Okay. Everybody should at least be able to get the 180. If you got 0.04 or 0.06, that's probably okay. But you should definitely have the 180. And over here, you should definitely have the 430.3. Okay, so this part you got to have. This part you got to have. All right, over here, you should have 710 and then 3.5, because again, it's not quite 0.4, about halfway. All right, so again, everybody should have at least the 713.5. All right, over here you have the 67.85, and the 67 is 67.8. You've got to have. Now, if you've got 0.85 or 0.86 or 0.84, you can live with that. But the 67.8 is not negotiable. All right. So over here, again, remember with a graduated cylinder, you're going to measure the meniscus, the bottom of the curve. So again, let me go back to my pointer. So you're going to measure this bottom. And if you follow that bottom all the way over, it comes to the top of my pointer circle there. So that's 2, 2.1, 2.2, 2.3, 2.4. So this is right at 2.4 milliliters. Okay, this one is right at it. The bottom is right on 2.0. So that would be 2.00. Again, remember, we can go 1 decimal more than the smallest measurement. And here we have, this again is a typo in the textbook, so we're gonna ignore this. All right, so this would be 3 is down here somewhere. That would be 3.567. Okay, so 3.71 would probably be my answer there. Okay. Okay, so pause the video if you need to get those down. And then over here, this one again has a little typo in it, so we're going to ignore that. And it should be, you've got 13 here, and 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7. So this would be 13.7, maybe 13.71. Okay, and then we have 26.01. So it's a little higher. That meniscus is a little higher than 26. So that's where the 0.01 comes from. And then here, this is 50 and this is 51. So there's only 1 milliliter between the two. Okay. All right. So the reason this is 49 is because there's only 1 unit between there. So this halfway mark, that would actually be 49.5. And so it's, we look at it and you've got it's not, that's the 4, that's the 5. So it's almost to the 0.4, but not quite. So it's definitely past 0.3, which is right here, right? That's 0.3, and it's almost to the 0.4. So, all right, here again, excuse me, it's 94 to 95. So you got 94.51 because it's just a little past the 0.5. All right, and then we talked about unit conversions, And the thing to remember is any number is always over 1, right? You learn that in math class. And then, a conversion factor, 12 inches is equal to 1 foot. So this is actually equal to 1. Okay? So then when you multiply across the top, multiply across the bottom, you have 144 feet inches divided by 1 foot. Well, your feet cancel out, and you're left with 144 inches. So you have successfully converted 12 feet into inches. Okay? Another example using the metric system might be 1 kilometer converted to meters. Well, kilo means 1,000, so there are 1,000 meters in 1 kilometer. So again, we put kilometers down here because we want those bad boys to cancel out. And that's going to leave us with meters. So we multiply across the top, multiply across the bottom, and divide. And we're left with 1,000 meters. Okay. If we wanted something a little more complicated, we might try to say 407 centimeters is equal to kilometers. All right, so we're going to start with 407 centimeters over 1. We put centimeters down here because we want them to cancel out. So there's 100 centimeters in 1 meter, and there are 1,000 meters in kilometers. We put meters down here because they cancel out. All right, so that's going to leave us, when we multiply across the top, multiply across the bottom, 407 kilometers. 407 kilometers divided by 100,000. And so then that means this decimal is going to move 1, 2, 3, 4, 5 spaces. So our answer is 0.00407 kilometers. All right, so that's that. And then we had some practice. All right, so this is the practice. I'll post this with the video in case you're stuck at home and you don't have access to this. So what is the prefix for 1,000? What is the prefix for 0.01? Now, I'm not looking for the fraction version. I'm looking for the word that represents 0.01. Okay. How many decimeters are in 1 meter? You have a mass of 1.2 hectograms. How many grams does it weigh? Express 150 million in scientific notation. Express 0.00043 in scientific notation. If I weigh 180 pounds on Earth, how much will I weigh on the moon? What is the SI unit for energy? What is absolute zero on the Celsius temperature scale? What are the freezing and boiling points of water in the Celsius scale? And convert the following Kelvin temperatures to degrees Celsius. And why is the Celsius scale sometimes called centigrade? So that was the graded assignment today that everybody should have done. So I will post that, and everybody should make sure I get it. You could also just answer it in a document and email the document to me. That would be fine as well. All right, have a good day. Stay curious.